Om Shri Sai Ram. Previous class, we have studied some of the class of compounds, that is alcohol, aldehyde and ketones. Alcohol means it ends with OL and its functional group is OH. Then aldehyde, it ends with the AL, that is suffix means AL, ends with AL and its functional group is CHO. In the same way, ketone, its functional group is CO. Then suffix is 1. In this class, another organic compound is carboxylic acid. Carboxylic acid. Carboxylic acid is an organic compound. It ends with oic acid. Why it is oic acid? Just look at this, carboxylic acid, carboxylic, so oic acid, so ends with oic acid, or we say the suffix is oic acid. Then its functional group is COOH, very important, carboxylic acid, how it ends? Oic acid. It means propanoic acid, butanoic acid or hexanoic acid. Alcohol means it is always ends with OL, that is methanol, propanol, butanol. In the same way, aldehyde, it ends with AL, that is methanol, propanol. For example, ketone, it ends with 1. How it is? Methanol, butanol. In the same way, carboxylic acid, this organic compound ends with oic acid. Because of this, carboxylic, that is oic acid. And its functional group is COOH. One example for carboxylic acid, propanoic acid. Why it is propanoic acid is a carboxylic acid? Is it example for alcohol? No, it is not example for alcohol. If it is a alcohol, how we pronounce that one? Propanol. But it is propanoic acid, so it is a carboxylic acid. Propanoic acid. Now we want to write the propanoic acid. Propanoic acid. Now write the structural and molecular formula of propanoic acid. The method is same. Prop means how many carbon atoms? If meth means 1 carbon atom, eth means 2 carbon, prop means 3 carbon atom. First write the structural formula of this propanoic acid. Prop means how many carbon atoms? 3 carbons, that is 1, 2, 3. 3 carbon atoms. Then single bond between these carbon atoms. After that, propanoic acid means how it ends? What is the functional group of this carboxylic acid? COOH. So use this C and double bond O. Why double bond? Double bond because O means in its outermost shell, oxygen in its outermost shell, it contains 2 electrons. So this 2 electron shares electrons with this carbon, so double bond. Then OH. Now COOH is over, that is functional group is over. After that, count how many covalent bonds for this last carbon. 1 carbon, 2 carbon, 3 carbon and 4 carbon. So 4 bonds are over for this carbon. Now second carbon, how many bonds? 1, 2, 3 and 4. For this, how many? 1, 2, 3, 4. Just write hydrogen because it shares, this carbon shares electrons with hydrogen. So it is hydrogen. Now the structural formula of propanoic acid is, this one is propanoic acid or structure of propanoic acid. Now write the molecular formula from this. What is the condition? First write the molecular formula. In molecular formula, first write the functional group. Which one is the functional group in this? COOH. So write COOH first. Now this portion is over. COOH is over. Now how many carbons are present? 1, 2. So C2. Carbon 2. So C2. Then how many hydrogen? 1, 2, 3, 4, 5. So C2H5COOH is a molecular formula of propanoic acid. Very simple. Propanoic acid means carbon 3, so 3 carbons. After that you have to write the functional group, that is COOH, then the 4 bonds with hydrogen. So this is the structure. Using this structure you can write the molecular formula. How? First condition is you have to write the functional group first, that is COH. Then how many carbons are left? C2. Then 1, 2, 3, 4, 5. C2H5 COOH is a molecular formula of propanoic. Another example. Ethanoic acid. Yes, tell me. Ethanoic acid is a alcohol or aldehyde or carboxylic acid. Is example for carboxylic acid. Why it is example for carboxylic acid? Because it ends with the suffix oic. So oic means it is carboxylic acid. Now write the structural formula. How to write the structural formula? Ith means how many carbons? Mith means 1, ith means 2. So how many carbon? 2 carbons. 1, 2, 2 carbons. In between carbon atom there is a single bond. After that, ethanoic acid means it is a carboxylic acid. What is the functional group of this ethanoic acid? COOH. Use this C and O double bond, then OH. COOH. After that, this carbon 4 covalent bonds are over. 1, 2, 3, 4. For this carbon, only 1 covalent bond, second, third and fourth. It shares electron with hydrogen. Now, this is the structural formula of ethanoic acid. So this one is the structure of ethanoic acid. Using this, write the molecular formula. First, write the functional group COOH. Yes, COOH. Now, how many carbons are left? This portion is over now. 1 carbon, so C1. How many hydrogen? 1, 2, 3. So hydrogen 3. CH3, COOH is a molecular formula of ethanoic acid. This is the method of writing molecular and structural formula of any carboxylic acid. For example, it is not only for propanoic, ethanoic, butanoic, hexanoic, octanoic. For any carboxylic acid, we can use this method. Next type of organic compound is haloalkane. Now, haloalkane, it's a prefix. Why it is prefix? It starts with chloro or bromo. How it starts with? Chloro or bromo. Then its functional group is chloro means Cl. What is the functional group of chloro? That is Cl. What is the functional group of bromo? That is Br. This is bromo. Now, next organic compound is haloalkane. What is the prefix? Prefix means it starts with chloro or bromo. Then for chloro, what is the functional group? Cl is the functional group. For bromo, what is the functional group? Br is the functional group. One example. Chloropropane. Yes, tell me. Chloropropane is example for haloalkane. What is the condition for haloalkane? It starts with the prefix. It starts with chloro or bromo. Now, chloropropane is a propanol, is a propanol or propanoic acid? No, it's a different one because it is a haloalkane. Haloalkane, it starts with chloro or bromo. Now it starts with, this propane starts with chloro. So chloropropane means it is a haloalkane. Understood? It is a haloalkane. Now, chloropropane, write the structural formula. Write the structure from this propane first. What do you mean by prop? How many carbon atom it consists? Prop means mith, eth, prop. So mith 1, eth 2, prop 3. So 3 carbon atoms. 1, 2, 3. So prop means 3 carbon atoms. In between single bond. After that, write the functional group of this chloro. What is the functional group of chloro? Cl. So write Cl. Why Cl only one single bond? Because in its outermost shell, in its means in chlorine, which contains 1 electron in its outermost shell. So chlorine shares electron with the carbon. So single bond between this carbon and chlorine. Now for this carbon, only two lines. Two lines means two bonds, two covalent bonds, or we normally say two lines for this carbon, okay. How many lines required? 4 lines. 1, 2, 3, 4. Now for this 1, 2, 3, 4. For this 1, 2, 3, 4. Write hydrogen for this because it is a organic compound. It contains carbon and hydrogen. So this is a chloropropane, structure of chloropropane. From this, write the molecular formula. First write the functional group. Cl is a functional group, so Cl. Now count the number of carbon. 1, 2, 3. So how many carbon? 3 carbon. That is C3. Then count the hydrogen. 1, 2, 3, 4, 5, 6, 7. So C3, H7, Cl is a chloropropane. Is the molecular formula of chloropropane. In the same way, chlorobutane, chlorohexane, chlorooctane, we can write the molecular and structural formula from this method. Another example, Bromo Propane. Bromo Propane. Yes, tell me. Is it a haloalkane? Yes, it is also a haloalkane. Why? What is the reason? Because it starts with the bromo. So bromo, haloalkane which starts with chloro or bromo. So bromo propane, it is also a haloalkane. From this, write the structural formula. Prop means how many carbons? Same. 1, 2, 3. So 3 carbons. Prop means 3 carbons. Then which one is the functional group for bromo? That is Br. That is Br. Right? Br. Bromium. Actually, what is Br? Br means bromium. In bromium also, outermost shell, it contains only 1 electron. So only single bond. After that, for this carbon, 2 lines, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is for hydrogen. This is structural formula of bromo propane. Now write the molecular formula. First write functional group, that is Br. Then how many carbon? 1, 2, 3, that is C3. How many hydrogen? 1, 2, 3, 4, 5, 6, 7. So C3, H7, Br. Just look at the difference. What is the difference between this chloropropane and bromopropane? Chloropropane, its molecular formula C3H7. Just look at it. C3H7. Both are same, but this one is Cl, this one is Br. There is a difference. In this, carbon, hydrogen and chlorine are the different atoms present, but in this, carbon, hydrogen and bromium, both are not same. They are different because in this chlorine, in this bromium. This is about haloalkanes. Just look at the series. CH3OH, C2H5OH, C3H7OH, then C4H9OH. These are the molecular formula and series is given. Why it is series? Because C1, C2, C3, C4. So it is a sequence of compounds. It is called sequence of compounds. Which one is the functional group for this sequence of compounds? OH is a functional group. OH is a functional group. OH is a functional group. For every compound which contains OH as a functional group. So OH is a functional group for this sequence of compounds. OH means it is a alcohol. OH means if any compound which contains OH as a functional group, then it is called alcohol. So it is a alcohol. But these are different alcohols. Why? Only 1 carbon, so it is a methanol. 2 carbon, so it is ethanol. 3 carbon, so it is propanol. 4 carbon, so it is butanol. So they are different. Their names are different, but these all are alcohols. Why? Because they have the same function group. This one is methanol, ethanol, propanol and butanol. But this sequence of compounds which have the same functional group and their chemical property are also same. Therefore, they are called homologous series. Why their chemical property is same? Because These compounds, this sequence of compounds contains OH, 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 OH. It is a functional group. They contain same functional group. We earlier studied about functional group. What is functional group? The group of atoms which are responsible for the chemical reaction or chemical property. So, this OH, they are responsible for, this group of atoms, they are responsible for the chemical property of that compound. So, every sequence of compound which contains OH as a functional group, therefore, they have same chemical property and they have same functional group. Therefore, they belongs to homologous series. It means the methanol, ethanol, then propanol, butanol, they are homologous series. Or we can say the sequence of alcohols belongs to homologous series. It means all alcohols, the series of alcohols, they belongs to homologous series. Not only alcohol, for example, the aldehydes, it means the propanol, butanol, hexanol, they belongs to homologous series. Why? What is the condition for homologous series? The sequence of compounds which have the same functional group and their chemical property also same means they belongs to homologous series. So these belongs to homologous series. Not only has, therefore, the aldehydes, the sequence of aldehydes, they are also homologous series. The sequence of alcohols, they are also homologous series. The sequence of ketones, they are also a homologous series. Now another condition for homologous series. Just look at this. C4H10. Yes, tell me. Now we already studied about different alkane, alkenes and alkynes. Just tell me, what is the name of this alkane? Why it is alkane? Why it is not a alkene? Why it is not a alkyne? C4H10 is a alkane. Just name the alkane. It is a alkane because what is the general molecular formula of alkane? CnH2n plus 2. Just double the carbon and plus 2. So CnH2n plus C4, double this. It gets 8 plus 2 and it is 10. C4 means meth, eth, prop, but. So it is a but. Now it is ane, alkane. So it is a butane. Next sequence of this is C3, H6, H8. Double this. Carbon double, if we double, it becomes 6. Plus 2 means 8. So alkane. For condition it is. It is a condition for alkane. C3, meth, eth, prop. So it is a propane. Sequence of alkanes. This is a sequence of alkanes. Now subtract this sequence of alkanes. What we get? 4 carbon atoms. Here it is 3 carbon. 4 minus 3. What we get? Only 1 carbon. 10 hydrogen, 8 hydrogen. If we minus 8 hydrogen from 10, 10 minus 8, what we get? 2 hydrogens. So CH2. Another example. C3H8 minus C2H6. This is a sequence of alkanes. C3 means it is a propane. C2H6 means it is a ethane. If we minus, subtract, what we get? C3 minus C2 we get C, C1, 3 minus 2, 1, 8 minus 6 we get H2. The difference is CH2. This is about alkanes. Another example. C6H12. It is an alkene. CnH2n formula. CnH2n. So C6H12 is the alkene. Which alkene? Hexene. Now another sequence is C5H10. Just minus this. Subtract. What we get? 6 minus 5, 1. That is C1. H12, H10. 12 minus 10 is 2. Just look at this. What is the difference between two sequence of alkane or alkene or alkyne? For example, alkyne. C6H10. This is alkyne. C5H8. This is a sequence of alkynes. What is the difference? 6 minus 5, 1. C. 10 minus 8, that is 2. From this example, what we conclude? We conclude that the sequence or consecutive hydrocarbons or alkanes, their difference is CH2. Their difference is CH2. If their difference is CH2 means they are also belongs to homologous series. So all alkanes or sequence of alkanes also a homologous series. The sequence of alkenes also a homologous series. Why? Because the two consecutive carbons, its difference is always CH2. Therefore, they belongs to homologous series. So, what do you mean by homologous series? Sequence of compounds with the same functional group and same chemical property in which the members of the series can be branched or unbranched. Then they differ by CH2. Then they are called homologous series. So, in this class, we have studied about homologous series and some of the organic compounds. Sai Ram.